let us try to solve some problems on discrete random variables on CMS and CPS. Let us take the first problem. It is defined as let x be a discrete random variable with range Rx is equal to 1, 2, 3, so on up to infinity. Suppose the PMF of x is given by Px of x is equal to 1 over 2 to the power x for all values of x varying from 1, 2, 3 up to infinity. We are supposed to find and plot the CDF of x, that is fx of x, and we need to find the probability for all the values of x between 2 to less than 5 and find the probability, that is the CDF, to x value greater than 4. Let us first validate this as a PMF function. We know that the sum of all the values should be equal to, for different values of x varying from 1 to infinity, sum of all these should be equal to 1. So summation of x value varying from 1 to infinity, Px of x is equal to summation of x value varying from 1 to infinity, 1 over 2 to the power x is this is a geometric function. So therefore we will get geometric series. So we get this as 1. So let's find the CDF for all values of x less than 1. This PMF function is equal to 0. So fx of x is also equal to 0. For all values of x between 1 and less than 3, we have Px of 1, that is equal to half. For values of x equal to 2 and greater than 2 and less than 3, we have Px of 1 plus Px of 2, that is equal to half plus 1 by 4 equal to 3 by 4. We can calculate here afterwards between 3 to 4, 4 to 5 up to infinity. Let us try to get the generalized function formula for CDF, that is given by fx of x is equal to Px of 1 plus Px of 2 plus Px of 3 up to Px of k, and for all values of x varying between 0 to k, that is half plus 1 by 4 plus 1 by 8 so on up to plus 1 by 2 to the power k. Half is taken out, so we have 1 plus half plus 1 by 2 to the power 2 plus so on divided 1 plus 1 divided by 2 to the power k minus 1. This is a geometric series. By applying the formula, we get this as half into 1 minus half to the power k, 1 minus half. That is 2 to the power k minus 1 divided by 2 to the power k. This is the CDF plot we have. Between 0 to 1 it is 0, 1 to 2 is half, and if 2 to 3 it is 3 by 4, and it is 4 to 5, 3 to 4 it is 7 by 8, so on. Part B, we need to calculate the probability between the x values between 2 to 5. Two ways we can solve this, either using the CDF function or using the PMF function. So let us make use of the CDF function. So it is 5 here, so fx of 5 minus fx of 2. So fx of 5 we can get from this, 2 to the power 5 minus 1 divided by 2 to the power 5, that gives us 31 by 32 minus fx of 2, 2 to the power 2 minus 1 divided by 2 to the power 2, that is 3 by 4. That gives us 7 divided by 32. Or we can make use of PMF function, that is Px of 3, because x value should be greater than 2. So therefore Px of 3 plus Px of 4 plus Px of 5, that will also give us 7 by 32. Part 3, that is C, we need to compute the probability for all values of x greater than 4, that is equal to 1 minus probability function of x less than or equal to 4. So that is 1 minus fx of 4, this is the CDF function. So therefore we get 1 minus 15 by 16, that is 1 by 16. Let us try to solve the second problem. The probability mass function Px of some discrete real value of random variable is given in the table. First we need to find the missing value Px of 2, and we need to draw the histogram of Px, find the cumulative distribution function fx of x, then we have to draw the CDF plot. So let us try to find out Px of 2. We know that the sum of all these probabilities should be equal to 1. So therefore, we have Px of x equal to 0 plus Px of x equal to 1 plus Px of x equal to 2 plus Px of x equal to 3 plus Px of x equal to 4 should be equal to 1. So therefore, Px of x is equal to 0.35, 0.15, Px of x equal to 2 plus 0.1 plus 0.2 is equal to 1. This will give us Px of x equal to 2 is equal to 0.2. So here we can write this as 0.2. We can complete the table. So we have this as 0.2. This is also given as fx of 2. This plot gives us the histogram of PMF function. For 0 it is 0.35, and for 1 it is 0.15, and for 2 it is 0.2, and it is 3 it is 0.1, so on. Then we have to calculate the CDF. For all values of x less than 1, PMF function is not defined. So therefore, fx of x equal to 0. For values of x between 0 to 1, we have only Px of 0, that is 0.35. For that has been plotted here. For 0 to 1, its value is 0.35. For x value between 1 to 2, we have Px of 0 plus Px of 1, that is 0.35 plus 0.15, that gives us 0.5. So between 1 to 2, we have 0.5. For values of x between 2 to 3, we have Px of 0 plus Px of 1 plus Px of 2, that is 0.35 plus 0.15 plus 0.2, that gives us 0.7. So between 2 to 3, we have 0.7. For values of x between 3 to 4, we have Px of 0 plus Px of 1 plus Px of 2 plus Px of 3, that is equal to 0.35 plus 0.15 plus 0.2 plus 0.1, that gives us 0.8. So therefore, between 3 to 4, we have 0.8. For all values of x greater than 4, we have Px of 0 plus Px of 1 plus Px of 2 plus Px of 3 plus Px of 4, that gives us 0.35 plus 0.15 plus 0.2 plus 0.1 plus 0.2, that is equal to 1. That is being plotted here. For all values of x greater than 1, this value is equal to 1. We solve the third problem. For each case, we need to determine the constant c so that the following function satisfies the conditions of being valid probability mass functions. For probability mass functions, we have already defined 3 properties. We will make use of these 3 properties to solve this problem. First problem, it says that all values of x belonging to x set, that is minus 1.5, 1, 2.5, Px of x is equal to x to the power 3 divided by 6. Let us apply the first property. It says that Px of x, that the probability mass function should be always positive. F of x should be always greater than 0. Suppose if I take the first value, that is x value is minus 1.5, then this x to the power 3 turns out to be negative. Since this has to be positive, which means that c value should be negative. If I take the next value, that is 1, here we know that the numerator value is positive. So here c is negative, so this turns out to be negative. For this, when x value equal to 1, c should be positive, so that this value becomes positive. So therefore, we cannot satisfy both the condition at once. So therefore, we don't have a PMF function defined for this. We'll take the second one. For all x value belonging to x, and n belonging to n value is greater than or equal to 1, qx of x is equal to 3 by 2 divided by 2 by 3 to the power x. We'll apply the first property of PMF. Once again, it says that its function f of x should be greater than 0. It should be always positive. Second property says that, which means that c must be positive, because if c is negative and if x is minus, if x is 1, then this becomes minus. So therefore, c should be always positive from the first property. We'll apply the second property. It says that sum of all the probabilities should be equal to 1. So it is x value varying from 1 to infinity, 3 by 2, 2 by 3 to the power x should be equal to 1. When we simplify this, we get the value of c is equal to 5. We'll solve the third part of this problem. X belonging to x, that is equal to n. Qx of x is defined as 3 into 2 to the power x divided by x factorial. Let us make use of this formula, which gives you n value varying from 0 to n, a to the power n divided by n factorial is equal to e to the power a. We'll apply this. Here it is 3 into 2 to the power x divided by x factorial, and the summation 0 to n is equal to 1. Here the value of a is equal to 2, so therefore it is e to the power 2. 3 into e to the power 2 should be equal to 1. When we simplify this, we get c equal to e to the power 2. Let us take the fourth problem. Here the CDF values are given to us. Using these CDF values, we have to calculate probability mass function of B. Let us try to solve this problem. Initially, they have given us f CDF of all values of B less than 0. It is 0. So this should be equal to fb of B less than 0 equal to 0. So probability mass function will be equal to CDF. And second data, using the second data, fb of B value greater than or equal to 0 but less than 1, this is given as 0.5. This is the fb of 0. So that is equal to 0.5. Next we have got fb of, it is this b value is greater than or equal to 1, less than 2, it is given as 0.6. That is sum of fb of 0 plus fb of 1, which gives us fb of 1 is equal to 0.1. Then we have the next data, that is fb of b value is greater than or equal to 2 but less than 3. This will be equal to 0.8. It is the sum of fb of 0 plus fb of 1 plus fb of 2. Solving this, we get fb of 2 is equal to 0.2, because fb of 0 is 0.5, fb of 1 is 0.1, so 0.8 minus 0.6, that gives us 0.2. Next data is given as fb of all values of b greater than or equal to 3, less than 3.5, its value is equal to 9 by 10, that is 0.1. It is the sum of fb of 0, fb of 1, fb of 2 plus fb of 3. So using this, we can get fb of 3 is equal to 0.1, because fb of 0 is 0.5 and fb of 1 is 0.1, that's 0.6, fb of 2 is 0.2, so that is 0.8. 0.9 minus 0.8 will give us 0.1. Lastly, we have fb of all values of b greater than or equal to 3.5. That will give us, it is equal to 1, and it is a sum of fb of 0 plus fb of 1 plus Fp of 2 plus Fp of 3 plus Fp of 3.5. When we simplify this, we get Fp of 3.5 is equal to 0.1. Let us take the fifth problem. Here x is defined as the num of the numbers showing on a pair of dice when they are rolled. Find the PMF of x. So each die has got 6 numbers varying from 1 to 6, and here we have 2 dice. So x is the sum of the dice 1 and plus dice 2. So here we can have 36 possible outcomes, each having a probability of 1 divided by 36. So you can form a table. Here you can have D1, here you can have D2. When D1 shows 1, D2 can show 1, D2 can be 2, D2 can be 3 or 4, 5, 6. When D1 has 2, this can be 1, 2, 3, 4, 5, 6. Similarly, when D1 has 3, D2 can take 1, 2, 3, 4, 5, 6. And similarly, we have here when D1 takes 4, D2 can take 1, 2, 3, 4, 5, 6. And when D1 takes 5, this can take 1, 2, 3, 4, 5, 6. When D1 is equal to 6, this can take 1, 2, 3, 4, 5, 6. And if you see that total number of outcomes is equal to 36. So it has here 36 possible outcomes, and if I take each case, it is unique in nature. 1, 1 I cannot get anywhere else. So, or 1, 2 I cannot get anywhere else. So therefore each one has a probability of 1 divided by 36. The smallest possible value of x what I can get is 1 plus 1, that is 2. So x equal to 2, that is equal to 1 comma 1. And there is only one outcome resulting from s equal to 2. Therefore, I have the probability of Cs of 2 is equal to 1 divided by 36. Now, similarly, we can take s equal to 3. And s equal to 3, I can get here, the combination can be here. You can observe here, it is 1 here, it is 2 here. 1 plus 2 can give me 3. Or I can have here 2 and 1. So 2 plus 1 can give me 3. So I have two possibilities here. Either it is 1, 2 or 2, 1. So that Cs of 3, I have two possible outcomes. So 2 divided by 36 is the probability mass function. So similarly, we'll calculate for x equal to 4. So x equal to 4, I can get here from here, this can be 1 and this can be 3, or this can be 2 and this can be 2, or this can be 3 and this can be 1. So I'm going to get three possible outcomes for x equal to 4, that is 1, 3, 2, 2, 3, 1. So therefore it is the probability of getting 4 is equal to 3 by 36. Similar way, we can calculate for x equal to 5. So x equal to 5, the possible ways I can get is here. One is here 1 and this is 4, and here it is 2 and here it can be 3, and then I have 3 and it is here 2, and then I have here 4 and then here it is 1. So I have here 5 for x equal to 5, I have 4 possible outcomes. They are 1, 4, 2, 3, 3, 2, 4, 1. So therefore probability of getting sum as 5 is equal to 4 by 36. So probability of getting sum as 6 is 1, 5, 2, 4, 3, 2, 4, 2, 5, 1. So there are 5 possible outcomes. So therefore the probability of getting sum as 6 is 5 by 36. Same logic can be extended for x equal to 7. The sum should be equal to 7. We can get here 6 possible combinations. 1, 6, 3, 4, 4, 3, 5, 2, 6, 1, 2, 5. So PS of 7 is equal to 6 by 36. And next one is x equal to 8. There are 5 possible combinations. 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. So therefore 5 out of 36 is the probability of getting 8. X equal to 9, we can get here 4 possible outcomes. 3, 6, 4, 5, 5, 4, 6, 3. So probability of getting 9 is 4 out of 36. And the next one is probability x equals sum equal to 10. We have 3 possible outcomes. 4, 6, 5, 5, 6, 4. So PS of 10 is equal to 3 out of 36, 3 by 36. Probability of getting sum equal to 11 we need to calculate. So there are 2 possible outcomes, 6, 5 and 5, 6. So PS of 11 is equal to 2 divided by 36. So finally we have probability of getting the maximum value sum, that is equal to 12, that is 6, 6. So PS of 12 is 1 divided by 36. Thank you. In the next video, we'll try to study continuous random variable.